Hi, I am Pankaj Patil. Today we are going to answer this question. Why does ice float in water? So generally when we think any solid, when it is converted from liquid to solid, it becomes denser. And when it becomes denser, it sinks in that liquid. But water is the only exception. When water turns into the ice, its own solid, the water becomes less dense. It doesn't sink, but it floats in water. So ice floats in water. This is the fact. And for that, we need to understand the structure of each water molecule. So if you consider this water molecule, this oxygen is bonded to two hydrogen atoms through a covalent bond. So first of all, if you consider electronic configuration of oxygen, oxygen has 6 valence electrons. It means it could use these 6 electrons for bonding. So there is a concept of octet. So when any element completes its octet, it becomes stable. When it has 8 electrons in its valence shell, it becomes stable. So it has 6 electrons and oxygen needs 2 electrons. So how does oxygen complete its octet? So it shares these 2 electrons. These black are the electrons of oxygen and these orange balls are shown, which are representing the electrons of hydrogen atom. This oxygen shares 2 electrons with 2 hydrogen atoms. Now if you consider total electrons around oxygen, these 2 lone pairs means they are non-participating electrons. These are called lone pairs. So total 4 electrons, 4, 5, 6, 7, 8. So around oxygen there are total 8 electrons. Now you expect it to be happy because it has completed its octet. It should be happy, but it is not, because this oxygen is very greedy, electron greedy. It needs electrons, more electrons, more electrons, more electrons. So what it does, this oxygen, this is called electronegative. This is electronegative element. So this oxygen pulls this shared pair of electron between oxygen and hydrogen slightly towards itself from both the sides. And because of this partial shifting of electron pair between oxygen and hydrogen, this oxygen acquires partial negative charge. And these two poor hydrogen atoms from which the electron pairs have been shifted away, they acquire partial positive charge. Now what happens? There is partial negative charge and partial positive charge. Now this is called polarity. Now this molecule has become polar. If you consider this positive part of one water molecule, that is hydrogen, positively charged hydrogen, it gets attracted towards the negatively charged, partially negatively charged oxygen of another water molecule, and the force that exists between the positively charged, partially positively charged hydrogen and partially negatively charged oxygen, that force is called as hydrogen bond. So this is hydrogen bond. This is not actual bond, this is just an electrostatic force. So one hydrogen bond, second hydrogen bond here, third hydrogen bond, fourth hydrogen bonds. So there are total 4 molecules around each water molecule. So these are called hydrogen bonds. If you consider liquid water, because of these hydrogen bonds, if you consider the specific heat capacity of water, means if I give 1 kilogram of water, the amount of heat required to raise the temperature of 1 kilogram water through 1 Kelvin is much more. So you require 4184 joules of heat energy to raise the temperature of 1 kilogram of water by 1 Kelvin. It means water has high heat of capacity because of these hydrogen bonds. And because of this high specific heat capacity, water bodies can store more heat without much change in temperature. If you see oceans, rivers, they can store large amount of heat because of this property. Now consider this molecule again. We have considered the hydrogen bonds. These molecules, water molecules, are not static. If you consider any water molecule, there is bending, stretching, spinning, and they are moving through the space. So all these motions are happening, and because of kinetic energy, they do have kinetic energy. Because of this kinetic energy, all this motion of heat energy, these hydrogen bonds are constantly making and reforming, constantly breaking and reforming. So these hydrogen bonds are not static, these are flexible. So hydrogen bonds break and again form. Now if you consider or if you lower the amount of heat in liquid water, so if you remove heat, what happens? It will freeze. So if you remove heat, means you decrease kinetic energy. When kinetic energy is decreased, the molecule should come closer, and the solid it should become denser, but it doesn't happen. The molecule doesn't these molecules don't come too much closer in case of water. So why? If you consider the kinetic energy becomes lower and lower and lower up to 4 degrees Celsius. Below 4 degrees Celsius, what happens? Below 4 degrees Celsius, the kinetic energy decreases. It becomes lower than the intermolecular bonding or hydrogen bonding. So kinetic energy is not able to break that hydrogen bonds right now in case of solid ice. So what happens? These molecules get locked inside hydrogen bonds. Hydrogen bonds now become the network. There is more space, and less molecules are placed in that space. So it means it is less dense. That is the reason ice floats in water, and that's why the aquatic life survived. And through the course of evolution, we have derived we have evolved from this aquatic life. Aquatic life survive below these layers of the ice, because once the layer is formed, the lower parts of the river or any water body, that remains insulated, because ice is the bad conductor of heat. It insulates the inner water body, so heat cannot be transferred outside, or outside heat cannot be taken in because there are no free electrons in ice to conduct the heat. So that's the reason ice floats in water, and all the aquatic life survives because of this reason. Thank you.